Good evening, ma'am. How are you? Hello, Dalia. Hello, Dalia.
Hello. Ma'am, I'm talking from Zoom. Whether my voice is coming or not, please tell me.
Good evening, ma'am. Good evening, ma'am.
Good evening.
How are you, ma'am?
Okay, I'm fine, ma'am. Okay. You carry on, ma'am. Okay. Bye. Yes, good evening, Asha, ma'am.
Ma'am. Yes.
Okay.
It's raining. It's raining heavily here. It's like a storm here in Attapur.
Yes, everywhere, not only there.
Everywhere.
Okay. Yes.
I thought I am only in the rain.
You are only in the rain. You are only in the world.
Acha. Okay.
Okay, let us join. Only 4 or 3 are there, I think so, including me. 4 are there.
Okay.
3 minutes will wait, then we'll start. Okay. Meanwhile, if people
Let's
have any sort of doubt from the last class, you can ask me.
Ma'am, which lesson, which I mean, say book we are going to follow? The C7 or C5?
Oh my God, C7.
C7, no? Okay.
Yeah. Hello. Durgesh, you can join. Good evening. You can join. Oh my God, what we'll do?
Ma'am, you left the meeting now, so I have become host of the meeting now.
Okay. Yes. Durgesh, we'll wait for 10-15 minutes. Still it is not coming, means please let me know.
Okay, ma'am.
Let me wait.
Okay.
Ma'am, good evening. What did I say?
Yes, ma'am, I heard. We will wait for some time.
Durgesh said he has power problems, so he did not join, it seems. Because of heavy rain. For me, when the power will go, I don't know. For you, when it will go, we'll wait for 10-15 minutes. If at all coming
we'll
means...
wait for 10 minutes, ma'am. We'll wait for 10 minutes.
Okay. Meanwhile, if you have any doubt, you can ask me from the last class, previous class, or exam point of view, anything if you have, you can use me now. I am little free. Got my point? Got my point?
Yes, ma'am. Yes. Yes, ma'am. Yes, I got it.
Yeah. Why you are losing the chance of using it?
Mm.
Some people are sleeping and showing are what idiots.
Nothing. I
Yes,
just,
ma'am.
sometime back only I came from school. I just sat for your class.
30 I have it. Still if you came late means what? Actually we are getting wake up. You are not there. To every one of you. Due to heavy rain, many people could not join the class, so we are waiting for another 10-15 minutes. Many people are asking like that, so please excuse. Hello, can you hear my voice?
Yes, ma'am, I can hear you.
Okay, fine. To others also I said.
I will put in the group, madam, to join for your class.
Okay, fine.
No need? Shall I put?
Yeah, you can join. Master madam will be already she started, but she is waiting
Ah,
for
yes, ma'am.
like that.
Yes, ma'am. Okay, ma'am.
Okay, fine.
Ma'am, we have only 7 participants, ma'am. Hello, ma'am. Ma'am, can you hear me? Ma'am, your sound is very low. Your sound is very low.
Actually, I didn't know. I'm not talking in Zoom. I'm talking over the phone. I'm asking.
Okay. Okay. Sorry. I thought you were talking in the class. Okay.
Okay. Let me finish. Actually, I have power problem. My power has not for me also. Hello.
Yes, ma'am. Tell me. No, I think only 7 members have joined, ma'am.
That is okay, ma'am. I don't have power.
Power is not there. Okay.
Yes. Then how could I handle? I can handle it. I can speak. Is it okay for you people? I can.
Good evening, ma'am.
Okay, ma'am. It's fine, ma'am.
What will do?
You can speak, ma'am. That's okay.
Let's start, ma'am.
No, the thing is,
Yeah, you can start, ma'am. We will listen. You can start, ma'am. We will listen.
Sorry, people are not understanding. I don't know. Okay, let us start then. No issue. Let me call Dukesh because he called me 2 times.
Okay.
I will tell him to join. Otherwise, anyone can send WhatsApp message to him. Now you can join the class. Madam, till now she was waiting for you. 1 minute, please. Now you can join. Okay. Thank you. Okay. Hello. In last class, what we have done? Anyone of you can tell me what we have seen in the last class? Hello. Hello. Hello.
Yes, ma'am.
Yes, we'll start now. No problem.
Okay, ma'am.
Whatever we have made use of that, I start explain. Any one of you can little brief about the last class? Any one of you can? Hello. Are quickly, please mute yourself. Please, you mute yourself, every one of you. Let me talk. Can you understand me? Can we start? Okay. Hello. Okay. In last class, what we have seen? I will give you a little brief. In last class, we have seen different stages of water treatment and some of the major treatment along with auxiliary treatment. Auxiliary treatment, selection of auxiliary treatment, which depends upon what kind of water is being used. So in continuation of different stages of water treatment, in this particular class, I'm going to talk about only aeration process. Can you hear my voice?
Yes.
Hello.
Yes, ma'am. We can hear.
Okay. Fine. Because here heavy rain, thunder also is there. That's what I'm telling. Okay. So in this particular unit, I am going to talk about only aeration process of water treatment for especially purification purpose. Why we have to do this process? This process particularly used to remove the undesirable gases which are all dissolved in water, especially specifically in groundwater, that gas is supposed to be removed. Otherwise, what will happen? Which imparts unwanted color, unwanted taste, and also which gives unwanted smell. To remove all those things, whatever the gases are dissolved in water, when it is in underground, those gases supposed to be removed by this aeration process. It is more often used only for groundwater only. Very rarely, something like paper industries, when they are doing the recycling of cardboard, those industries people, when they are discharging large quantity of water which contain organic substances in the form of sludge form. So for particular those type of industry, they are using this kind of aeration process for converting those organic matter, that is complex substances, which will be converted into easily manageable form by this aeration process. These two particular uses only, mainly this aeration process is used, applicable. Actually, I am asking some of the gases which are all dissolved in water. What are they? Anyone can tell me? What are the undesirable gases or dissolved in groundwater?
Oxygen will be dissolved in water. Okay. And carbon dioxide. Also, I think some amount of hydrogen sulfide, ma'am.
Okay. Then
I have doubt about nitrogen, ma'am. I have doubt about nitrogen.
Nitrogen, no, nitrogen will not dissolve. Okay, it is not dissolved, soluble gas.
Okay, but ma'am, in the sea, oceans, the waste products of the fishes and all, they contain ammonia, na?
Yes, that is from that decomposition process, not by nitrogen fixing. Oh my God, you people are very clever. Nitrogen can be fixed by special bacteria which are all lying in the roots of plant. That is specialized bacteria. They are called rhizobium and acetobacter. These bacteria only have the capability of fixing of atmospheric nitrogen into some ammonium compounds that also happen in underground, in the roots of plants. Understand? Right,
okay, ma'am.
Okay.
Right.
If you said some of the carbon dioxide and hydrogen sulfide are dissolved in water. What are the sources for those gases? What did you say? It is correct. One more gas will be there that I will tell. Some methane also will be there. What is the main source for that gas? From where it comes, how it dissolved in water? Oxygen will be there everywhere, so it is not the factor to be considered much. I am talking about some other undesirable gases like hydrogen sulfide, methane, and the carbon dioxide. Those gases are dissolved in water. When the water is underground, what is the source for those gases? I will ask you one question from all of you. That Mangalyaan one satellite that people have sent into the space. Have you heard about it? Hello?
Yes, ma'am. Yes, ma'am.
Why they send? What is the purpose of it?
Really?
You know why they have sent? What is the role of that Mangalyaan? What it does? Why they have sent it? Before sending, they have published. When it was in space, they have published. After it came also, they have published. And continuation of that, they have sent something else also. You know what is the main purpose of Mangalyaan? Why they are sending to Mars especially?
I think to find out any other place in to live human beings.
Okay, in terms of what we can predict that. I not find out. They wanted to find it. I myself tell you, they wanted to find out that except Earth surface, any other planet may have any living things or not, or previously the living things lived or not. To wanted to find out that only they have sent with Mangalyaan. In terms of what it could be predicted. In terms of what it could be predicted. Come fast, don't waste the time. Shall I explain?
Yes, ma'am. Yes, ma'am, please.
Okay, I will tell you. Actually, these undesirable gases are coming out of, I will tell this later. Actually, why they have sent Mangalyaan into Mars? These people have some fluke, I can say fluke idea. In Mars, people would have lived, some living things would have lived, plants might be there, animals must be there, human being must be there. So this kind of story, because this Mars characteristics are like this, that X, Y, Z. Based on that, people have an idea about there must be living things. If it is not now, it would have been in earlier stage. That was the prediction they had, astrology. Then they said some of the things, if any living thing anywhere would have been there, means what it will be. All living things are what? They are all organic matter. Okay, how long it lives, how long it is not alive, those things are organic matter only. Either it is animal or plants, including human being, we are all organic matter. Once it is destroyed also, that is organic matter. If it is destroyed, everything destroyed, this organic matter will be decomposed. Once it is decomposed, means which releases this methane gas, carbon dioxide gas, and a little bit of hydrogen sulfide also. If anywhere these gases are available, it will be predicted, means we can say surely that there would be organic substances presented. If it is there, means any living things, either it is in the form of animal or plants, must be there. We can conclude that. For that conclusion only, these people have sent Mangalyaan into the Mars. Okay. Likewise, now we are talking about this groundwater undesirable gases, which are all in the form of methane, carbon dioxide, hydrogen sulfide. So where it will come and how it is dissolved in groundwater. These gases are released from the decomposition of organic matter, which are all present in underground. When the gas is released, it will be dissolved in the nearby groundwater. So which makes as water dissolved form of all these gases. When it comes out of these gases along with the water from groundwater to surface, this carbon dioxide, which influences many process like further treatment process which are affected, and also which result in corrosive problem to the utensils and boiler, whatever it may be the application. And hydrogen sulfide, we know that. Anyone of you, can you tell me please what is the smell of hydrogen sulfide? How we can find out the hydrogen sulfide, it is there or not? What is the smell of hydrogen sulfide?
Ma'am, it smells like sewage water. Something like that.
Very good.
Sulfur.
Now I will ask you the question. Why the sewage water is smelling like that? Why the sewage water
maybe
like that?
Because of the decomposition, something like that, ma'am. Decomposition.
Composed matter of organic substances.
Okay. Have you heard about the smell of hydrogen sulfide at any time from the schooling till now?
Maybe in 10th class we did, ma'am, but don't remember.
Okay. I am telling one thing. Already I told you. It gives rotten egg smell. Okay. Hydrogen sulfide means it's a rotten egg smell. So from the smell itself, we can identify there is hydrogen sulfide used. Understood? It will be formed at any stage. Anaerobic condition is there. Whatever the organic substances are there, which will undergo this decomposition. Because of this decomposition, the hydrogen sulfide will be released. This hydrogen sulfide, which is a very bad smell. Understand? Very bad smell. That's what I told you, that gives rotten egg smell. Then you can imagine how it could be. So if it comes along with the groundwater, those water cannot be used for human consumption. So it has to be removed before it committed for domestic application. Okay, so the removal of that gas, carbon dioxide and methane, those gases supposed to be removed before it gets are distributed into the human application. And other gases, some of the minerals will be there. Can you tell me what is the main source of iron?
Iron, hematite. Iron ore, ma'am.
Hematite. Yeah, that is ore is okay. Hematite. 4, 5
Hematite,
ores are there.
magnetite.
Yeah, even I colsonite, hematite, magnetite, and one more are there. I forgot the name of it. Okay, those are all the ore. They contain more than 60 to 70% of iron content. So by mining process, they are separating. Iron is presented everywhere. Is it distributed widely or not? You people do one thing tomorrow. If it's possible to get small magnet from anywhere, small magnet, which is something like a small stone, we can consider little bigger than our Durdal size. You take that magnet, you take some soil anywhere in the earth surface. You just keep that soil on the paper and move the magnet above just like this, like gradually move the magnet on the surface of sand. How much iron particles will stick on that magnet? You look at this. The iron is only the material which is widely distributed on the earth surface. Okay, that iron along with the manganese, when it dissolved in water, which gives excellent taste to the water. If the quantity is exceeded into the limit, which gives the color to the water, that is from yellow to brown color. If it is less than concentration, the water taste will be less. If it is more concentration, the water will be.
Ma'am, sorry to disturb you, ma'am. Ma'am, which topic is this, ma'am?
Aeration. We are talking about unit aeration.
Aeration. Okay, ma'am. Okay, ma'am. I joined just now, no, ma'am. That's why. Okay.
You only shared the documents to everyone. No? You didn't open
it? Yeah, ma'am. Yeah, aeration. Yeah, ma'am. Yeah. Actually, I joined in the middle, ma'am. That's why.
Okay,
okay, ma'am.
Okay. So this iron and manganese are the important substance to impart taste to the water. At the same time, if the quantity is more, then this gives a color to the water from yellow to dark brown color. So this iron material, if these minerals, if it is not in oxidizing condition, then only it will be solubilized. For those soluble, this aeration process is used. Understood? Aeration is a process which is one of the important stage of water treatment, especially for groundwater treatment. I said why it is important. This process, especially, which removes the some of the dissolved form of gases, that is carbon dioxide, methane, and hydrogen sulfide. Those gases are released from the water to the atmosphere, or removed from water to atmosphere, and which gives some of the oxygen to the water. Because of that, the iron and manganese will be converted into respective oxide. Otherwise, those ions will be dissolved in water, which gives color, and sometimes if it exceeds the concentration, which impacts the color to the water, that is in the range of light or pale yellow to brown color. Understood now? Because sometimes they will ask what is aeration and write a note on aeration. This is the point. And the next one is, when we are doing this process, what exactly happening in water? We'll see. The first point is, when we are doing this aeration process, what exactly we are doing? We are supplying air into the water, which is nothing but, we can say in another way, we are giving oxygen to the water, and which is useful, especially which is impart the color and taste. I told you that. And sometimes when the oxygen level is little more, means this will be useful for oxidizing the organic matter which are present in the water to some extent, not completely. Okay, first point. And second important point, when in the recarbonation process, so especially after softening process, I told you what is softening and all. If the water hardness is more, we have to follow some softening process. For that, people are adding lime. During that process, if excess lime is there, means by adding of carbon dioxide, this aeration process, especially for the neutralization of causticity, that time also this process will be useful. And the carbon dioxide is also added to the water during this process, where water will contain high level of sulfide. In order to lower the pH value, it's increase the volatility of hydrogen sulfide. So the hydrogen sulfide removal from the water will be taken place efficiently. These two things are happening when we are doing the aeration process. These two processes are happening indirectly when we are doing the aeration process. And we are telling about the aeration.
Excuse me, ma'am. What do they do, like to remove hydrogen sulfide? They add excess of lime. Is that you are saying, ma'am?
No. Actually, this is what I am talking about. When we are doing the aeration process, what are the things will be added into the water? Because we are talking about, we are removing the gas and we are converting the iron and manganese into their respective as oxides. These are all we are doing one conversion, another one is removing. Anything could be added into the water we are talking. One thing we can add oxygen into the water. When we are adding the oxygen, which will be useful in two ways. One is it's oxidizing iron and manganese oxide, which impart the color, odor, and taste to the water, and also which converts or oxidizes some of the organic matter into the manageable crop, not completely, to some extent. One point. And the second one is substances that alter the characteristics of water when we are doing the recarbonization process after softening with excess lime. At that time, what is happening? When we are adding the carbon dioxide added by the aeration devices for the neutralization of causticity, which is caused by the lime during the softening process. That time, what will happen? This carbon dioxide is also added at the times during this aeration process to water, that whatever the sulfide is there, in order to lower the pH value, which increase the volatility of hydrogen sulfide, so it can be efficiently removed. That means volatility of hydrogen sulfide will be increased by this aeration process when they are doing the neutralization process with lime. In case if the lime content excess means, then again they have to increase the causticity by adding the carbon dioxide. That time this volatility of hydrogen sulfide will be increased, so it will be removed easily. Understood? Understood?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Sorry,
ma'am.
no one is there. My God. Okay, what is limitation of aeration? I'm telling that this is very simple process. Simply we have to pass oxygen or air into the water. This process can be followed up everywhere, or which will have any limitation or not, we'll see. For example, when the substances can be removed by this aeration process, when we can remove, when the substance have enough volatility, that time only we can remove. If it does not have enough volatility, those substances cannot be removed by this aeration process. For example, some of the water which has unpleasant smell, odor, taste, these are all, how this unpleasant smell, odor, color is coming into the water, I told you. Would you remember? The water is some color. The water is some unpleasant odor, smell. How it will come? Because of what it imparts the color into the water?
Ma'am, your voice very
I'm
slow.
not asking only groundwater. If the water contains some of the phenolic compound, or some of the phenolic compound will be mixing with the water. Yes, yes.
Not audible, ma'am.
Yes. My voice is not audible. I have to be little louder. Okay, no problem. No, why? What could be the reason for water smell, odor, and color? Because of what the water is getting color?
I think TDS and turbidity.
Hello?
Yes.
Hello?
TDS.
Yes.
Yeah, ma'am.
No. TDS is a reason which gives the turbidity. That is okay.
What is the question, ma'am?
What is the major source for color of water?
The source of water.
Which substance impart the color to the water? Okay, now few minutes before I told you, what are the minerals which gives the color to the water?
The interaction of the molecule.
No. Few minutes before I said, Nubia, Asha, you are not in the class.
Yes,
Hello?
yes, ma'am. Yes, ma'am. We are there.
Then what did I say few minutes before? What are the minerals are imparting the color to the water? Iron and manganese is there means which gives taste as well as which gives color from pale yellow to brown color. I said no.
Yes, ma'am. Yes, you have
What
said. You have
happened?
said. Yes.
And you people have forgot. You, oh my God, you will simply join and doing some other work. Huh?
No, ma'am. In middle where your voice is
There will,
getting cut, ma'am, actually. So
no, because of this rain, I also have signal issue.
yeah,
I
ma'am, there's
cannot
some
tell you
signal
that.
issue, I guess.
I
Half
thought, yeah.
of your voice is coming, ma'am. Half is cutting again half is coming. Yeah, ma'am.
Okay, if that is the case, if I speak this much volume, it is okay. Is it okay now? This much volume, if I am speaking, means
Yeah,
could
it's
you
okay,
able to
ma'am.
hear my voice properly? Okay, then
Okay,
this
ma'am.
with this much volume,
Yeah,
I'll
ma'am.
speak. Okay, and my question is, what is the source for color of water? This I have told you 4 times in this class today. If water contains iron and manganese, means which gives a taste. And, yeah, iron and manganese. These are all the source for giving the color and taste to the water. Now I am talking about limitation of aeration
No,
process.
minerals, ma'am.
This aeration,
Iron, manganese,
yeah,
and
yeah, these are all the important source to give the color when it present excess. In general, if you when we are talking about the wastewater, including sewage and industrial effluent, the color mainly is imparted by the phenolic compounds. As I told you, this I have told you in the last class. Isn't it? Phenolic compounds is only the source which gives the color to the wastewater. Now we are talking about the groundwater. For groundwater which gives color from the iron and manganese. Understood? Now I am talking about the limitation of aeration process. This aeration process is very good method to remove the substance when they are in volatile nature. And many substances which are giving problem to the water, they are not volatile. For example, some of the substances which are giving the color, odor, taste to the water, they are not volatile in nature. So those become a pollutant means that cannot be removed by this aeration process. That's what I wanted to tell you. Understand?
volatile means it is highly reactive, no, ma'am?
No, volatile means it is easily evaporable even at room temperature. Those are all called volatile compound. Volatile compound, volatile
Highly
chemical,
sensitive.
volatile. High sensitive, we can't say. It is easily evaporable. For example, alcohol.
Yeah,
Drinking alcohol, petrol. Many of almost all the hydrocarbons are volatile only.
It's highly
You keep
volatile.
the you keep the petrol outside for some time in a can, in a container. 100 ml petrol you take it, keep it outside.
It is highly
You
volatile.
leave it for 24 hours. After that, you will see there will be a petrol. I'm asking you people.
It is volatile.
Okay, those compounds are called volatile compounds.
Yeah, ma'am.
Clear? Again, I will tell you to every one of you, volatile compound means the compounds which are easily evaporable at room temperature, those compounds are called volatile compound. Volatile organic matter we have talked in air pollution, no? Could you remember?
Yes, ma'am. Yes.
Alcohol, ketones, acetone, oxide, formaldehyde, acetaldehyde, acetic acid, methanol, ethanol, many things are there.
Functional group. Yeah.
That time also I have mentioned about the petrol. Okay. Yeah. Those compounds, those kind of compounds, if it is solubilized in water, those chemical can be easily removed from this, removed by this aeration process. But the chemicals, many of them which are all giving the problem to the water, which are all non-volatile, those chemicals or those substances cannot be removed by this aeration process. Understood? Okay, for example, if you take this manganese iron, which cannot be removed by this aeration process, which can be converted from iron manganese to iron oxide and manganese oxide, not by removal. It is converting to one form to another form, but it is not removed. Clear? And also some of the microorganisms, for example, which disintegrate and release essential oil, those algae cannot be removed because they are not volatile in nature. And some of the algae, which is named called cyanura,
Only 50% can be removed and the remaining 50% will be retained in water only, because this aeration process will convert around 60% of organic matter into manageable form, which reduces the carbon dioxide level as well as organic load also. And when these are all the, when already I told another point that we cannot be removed iron and manganese. Sometimes this component will be converted into organic form of iron and manganese, that is still it became more stronger. Those can not at all be removed by this aeration process. These are all the limitation of aeration process. Understood? Whatever till I spoke.
Yes, ma'am.
About that, one question make. They may ask the question, what is aeration? And write a note about aeration and what is the limitation of aeration. Another one thing is a very important fact. I'm going to talk about theory of aeration. You look at the question paper right from starting to 2018 or 19. Either they would have asked what is the theory of aeration, or what is the theory of sedimentation, or what is the theory of filtration. Any one of these three questions compulsory will come. Okay, understood? Okay. And the next one is theory of aeration. What I'm going to talk, it is little complicated, but you people have to listen me carefully. If you cannot understand, you ask me. Now you can open your slides also. When I'm explaining this theory of aeration. Actually, we will think that the substances which are all present in the water, if it is reached in the saturation condition, what is meant by saturation?
Highest point, ma'am, nothing can be added to it.
It can't be dissolved anymore after that.
Yeah,
it can't
means
be
if yes, correct only. Saturation means nothing can be done after that. That's all. Okay. If you add more also, you cannot add. If you want to remove also, you cannot remove. That point is called saturation. Similarly, what is happening here? Any substances, when you are adding to the water, either it is less than or in excess of their saturation value, which change their concentration by this aeration process. Now we have told you that if anything it reached the saturation condition, we cannot be done anything. That is the definition we know. But that can be altered by this aeration process. Understood? With the saturated value being the limit of change of both the condition. Either it may be increased or it may be decreased. Did you get my point? When the substances, when we are any substance, when we are adding into the water, it reaches a saturation condition. Once it is reached saturation condition, means if you add further also nothing will happen. If you wanted to remove from that also nothing will happen. But by following this aeration process, that amount of concentration of substance can be altered either side, either on more side or less side. Clear? When it is reached like this, for example, now I am going to explain about in terms of dissolved gases. We know that oxygen, carbon dioxide, and hydrogen sulfide are highly volatile in nature, and their concentration in water also it is readily affected by this process because they are volatile in nature. Aeration is the process of removal of these volatile substances more effectively, especially when the water is warm condition, which will be removed more effectively than the cold condition. And this process is removed such as hydrogen sulfide, carbon dioxide, and methane also. Methane is ammonia and methane both can be removed. Ammonia is highly volatile compound. It is very strongly dependent upon the pH of the water. If lower the pH value, it improves the efficiency of aeration whenever the water contains insoluble form of hydrogen sulfide, carbon dioxide, and methane. Clear? This aeration, simply I will tell you, this aeration process which depends on pH and temperature, which works well in hot water condition than the cold water condition. If some of the volatile gases, hydrogen sulfide, methane, ammonia, and carbon dioxide present, mean the pH is supposed to be in very lower level. Then the efficiency must be more. If it is more, means it has to be heated, then it is economically not viable. That is the reason. So the efficiency of the process will be going down at a higher level, high pH. If it is lower, then it works well. And very important things I'm going to tell. Now, if you take any substances, either, now we are talking about the reaction between water and air. Aeration means which is nothing but we are supplying air into the water. So there is the interchange or reaction between the air and water. Something is happening because of that only this dissolved gases will be removed and oxygen will be dissolved. Because of that oxygen, the organic matter is being oxidized or converted into manageable form. These three things are happening. Now we consider the interchange of substances is taking place in water, that is from either water to air or from air to water. When it is taking place, we can consider that air-water interface. Okay. The air-water interface, the rate at which the interchange occurs, it is a result of concentration of the substances at the interface, which is rapidly formed and exposed. What is formed? When we are passing the air or oxygen into the water, there is a possibility of interchanging occur. When the interchanging is occur means air and water molecules started react. React in the sense there will not be any compound will form. When it go and attack oxygen molecules or air molecules with water, if anything excess is there in the water other than H2O, that is in the form of CO2, NH3, CH4, H2S, that will be removed. That is called either it is exposed or formed. Clear? That will be described in your equation by the two phenomena. One is gas absorption phenomena, another one is gas release. If the dissolved gases will be released, it means that is gas release. What is the phenomena? Some of the gases will be absorbed in the form of oxygen, that is formed dissolved oxygen, which will be useful for organic matter oxidation in the water. That is called gas absorption phenomena. For both the phenomena, they have given some equation in our book. Understood? Understood?
Almost.
Yes, ma'am.
Not so clearly.
Sorry, no one.
Yeah, ma'am.
Shall I
Yeah,
explain
ma'am.
one more time? Shall I
Yes,
explain
ma'am.
one more time?
Yes, ma'am.
Okay, what I'm saying, this aeration process, how it works, works and how it is carried on. That is called a theory of process. Now we are talking about the aeration. So theory of aeration means what? As I told you that if any saturation condition is reached in anything, the altering of concentration of those things are very difficult, but this aeration process can alter both sides, either a more side or less side which can alter. For example, any substances which presented in water in the form of volatile gases, those volatile gases are readily affected by this aeration process. The removal rate will be depending upon its pH as well as the temperature. The water is in hot condition, the removal will be faster. The pH will be lower level, that removal will be faster. These two they have considered. Then when we are coming into that aeration process which is nothing but the interaction between the air and water. Either it may react air with the water or water with the air. That they are called, technically they are called the interchange of substances from air to water or from water to air takes place. At that time, the interchange occurs. Interchange means exchange of molecule between air and water, which the interchange of molecule occurs because of the relative concentration of the substances, either water or air, which rapidly changes the concentration. By what? By what means when we are adding the oxygen or air into the water, which removes the dissolved gases and which absorb the oxygen. Clear? If it is released the undesirable gases as in the form of methane, carbon dioxide, ammonia, and hydrogen sulfate, what will happen into the water? If it absorbs the gases, that is in the form of organic matter, oxygen, which converts the organic matter present in the water into some manageable form, something will be released this in the form of gases also. So whatever the things absorbed that is called absorption phenomena. Whatever the gas are released, that is called gas release phenomena. For both gas release and absorption, they have given one equation in your book. Is it clear?
Yes, ma'am.
Okay, fine. For gas absorption, that they have given based on the concentration of molecules, Ct equal to, that you just to go through it. If I will explain also, nothing will happen. Okay. But simply I will tell, I wanted to tell only one thing. Gas absorption equal to Ct equal to Cs minus, within bracket Cs minus C0 into 10 to the power minus K by AV into T. Where Ct means gas concentration at that time. Cs means gas concentration at the saturation condition. Cs minus C0, which gives the saturation condition and the initial concentration of the gas molecule. And 10 to the power, that is constant to make the equivalence. Gas release means Ct equal to C plus and C0 minus Cs, that is a ulta, and the expression something. Now my question is, you people are aware of what is exothermic reaction and endothermic reaction? These
Yes,
two are
ma'am.
related to exothermic and endothermic. Okay. Now,
Yes,
gas absorption is endothermic or exothermic?
Gas absorption is endothermic. Yeah. Gas absorption is absorption. Endothermic.
By absorption, the heat will be added or it will be removed?
It will.
Ma'am, I think endothermic, ma'am, when it is released, it may release some amount of energy.
Okay, now I will come to the what is meant by exothermic and endothermic.
Exothermic
means it releases energy.
Heat is absorbed and exothermic is heat will be released. Heat energy will be released. Exothermic.
Please, again you tell me, what is that? I couldn't hear your voice.
In endothermic reactions, heat energy will be absorbed. And exothermic reactions, heat energy will be released. Along with the...
Release.
Yeah, heat.
Now, heat release means it is positive or heat absorption means it is positive?
Heat release,
I'm talking about the heat, not in the form of gas. Heat release is exothermic or endothermic?
Heat release is exothermic, ma'am.
Exothermic.
Okay. Heat absorption means endothermic.
Endothermic.
Now you leave the heat. Now you come to the point of substance absorption. If heat gas is released, then is exothermic or endothermic?
Ma'am, exothermic.
Okay. Exothermic
Madam,
is
please
positive or
explain
endothermic?
exothermic and endothermic, madam. Please explain the exothermic and endothermic also. Yeah.
Exothermic means from the process the heat is evolved to outside means that is exothermic. The heat is absorbed from the outside to the system, that is called endothermic. Is it clear?
Yeah, ma'am. Yeah, okay. Middle signal is going, ma'am.
Heat released, it is exothermic. Heat absorption is endothermic. Always exothermic is positive, endothermic is negative. Clear?
Yeah, ma'am.
Yes, ma'am.
Okay.
Adiabatic, ma'am, adiabatic is in the presence of...
No, adiabatic is different. That is closed open system. Adiabatic and isothermal means, I will tell you both. Isothermal means temperature remains constant throughout the process. If you add the heat or remove the heat, the temperature will be remaining constant. That is isothermal. Adiabatic means it is temperature changes will be there. There will not be any heat addition or deletion. Understood?
Yeah, ma'am. This adiabatic and difference between adiabatic and exothermic is here is about the temperature change.
In adiabatic, temperature changes will be there.
Okay.
Exothermic is also temperature changes will be there. Understood?
So both are similar, ma'am.
No, there will not be any heat addition or deletion. Nothing will be in this. Your heat released, no. In some cases, ideal cases, both will be implied. For example, you take an insulating system, any insulation system. What is the process? We are thinking that in temperature remains constant. Any insulation system, people are thinking that the temperature is constant. Based on that only, till now all the model has been developed. All the big industrial process, everything depending on that only. But they themselves will give the outside temperature. What is outside temperature? What is inside temperature? That gives some sort of heat transfer. Based on that heat transfer only, that decided that is the isothermal process. Understood? Isothermal means temperature remains constant. We are all having the concept that the temperature should not be changed in the system. If any heat addition will be taken place or heat deletion will be taken place, that is correct. You take your rice cooker, your pressure cooker, whatever the heat you are giving, once it reaches the particular temperature of 120 degrees centigrade and 1.5 to 2 bar pressure, if we give extra also, it will be retained and releases the pressure, further temperature will not be increased. That few minute condition is isothermal. Okay, it is pakka. But once you turn off the gas, then the temperature is started decreasing, but you are not giving any heat to the system. But there is a exchange of heat from the cooker to the outside. Yeah. Clear? First stage is isothermal, second stage is adiabatic. In this, when you are giving the heat to the system, that is endothermic, and the heat is released from the system is exothermic.
That is latent heat, no, ma'am. Whatever.
Latent heat means what? Latent heat means when you are heating the substance, especially water, if you heat the water continuously, the temperature will increase. Once it reaches 100 degrees centigrade, after some time, if you will give extra heat also, the temperature will not be increased after 100 degree. I'm not talking about the pressure cooker temperature. It goes up to 120 degrees centigrade. The corresponding pressure is 1.5 to 2 bar. Sometime 1.2 bar also it will be. The pressure will increase from atmospheric pressure to more. The latent heat system means when you are heating the water from the room temperature to 100 degrees centigrade, the temperature will increase very fast to 95, 94, 96, 97, 98, 99 onwards. And after reaching 100 also, the temperature will not at all increase. It will be retained there for quite a long time. That heat is called latent heat. Once the why it is not increasing the temperature means when all the water molecules in the container when it will be reaching that 100 degrees centigrade, that time whatever the heat energy or energy content is there in the water will be released or converted into steam. That heat is called a latent heat. If we give pressure extra, then the content temperature will be increased. Otherwise, the temperature will not be increased. Clear? That situation is called a latent heat. Is it clear?
Yeah, ma'am.
Okay. Can we go further?
Yes, ma'am.
Okay. Then the design of now this is whatever we have talked about, that is theory of aeration. That is very, very important question. Then a design of aerator. Design of aerator is also one of the important questions. Some of the here people have asked. You can find out. I will explain. And a few types are there. Based on the type, you just understand what could be. And based on that, you have to draw small diagrams. And right, you can score good marks out of it. Because the explanation wise, it does not contain much. You can write about the diagram, draw a diagram, write about the 2-3 points about the diagram, and cover all the model. You may get full mark for this question. Okay, design of aerator. We know that this is a process just we are supplying air into the water. How we can supply air into the water? Could you imagine? Or we can supply water into the air. What we can do that?
Water into air, ma'am.
With some medium, ma'am.
Okay.
We need a medium to supply.
Okay.
You can supply air into water also, ma'am.
Air into water, where you will supply?
We need a medium.
That is possible. Where you can do that? Some of the aerators are there.
Air blowers.
through that we can use. Please mute yourself. Noise is too much. I wanted to tell about the aerator. Both it is possible. We can pass water into the air media, or you can use some sort of device to supply air into the water. Both are possible. Both will explain. Okay. Which aerator, which is nothing but it is a device. The aerator is a device which is supposed to provide maximum surface area of water to the atmosphere to expose more, which provide the agitation of air which aid diffusion into the water. So that is the process. When it happens like that, whatever the solubilized gases will be removed from the water and oxygen will be added into the water. That is the process is taking place in aerator. Based on that concept, we have to design the aerator. Again, I will tell you, aerator is something like a design which is supposed to provide a maximum surface area and which separate or which includes atmospheric oxygen or air into the water surface. And in that air supposed to be provide the little agitation on the water surface. Because of that, the air is diffused into the water. Because of this diffusion, whatever the soluble gases are there in water will be liberated or evolved. And the oxygen is added into the water. This is the process of aeration which is taking place in aerator. In your book, this much clarity will not be there. Okay. If you want me to tell, again I will tell. If you understand, we'll go to the next.
Ma'am, please repeat again now.
Okay. Aerator, which is nothing but a device. Which device will be useful? Which is supposed to provide the maximum surface area of water and which separate or include the atmospheric air. Then what will happen? The air is giving the agitation into the water by diffusion. Air is diffused into the water. When it happens, this diffusion, whatever the gases are solubilized in water, like carbon dioxide, methane, ammonia, and hydrogen sulfide will be liberated from the water to outside, and oxygen is added into the water, and this oxygen will be useful for oxidation of organic matter which present in the water. This is the thing is happening in all the aerator process. Understood?
Yes, ma'am.
Yeah, ma'am.
Okay, fine. Okay. These aerators are, in your book, it is not very clear. If you read 10 times also, it's quite difficult to understand. Aerators are broadly classified into 3 important types based on the operation. Not on the design is classified based on the operation. One is gravity type, second one is diffused type, and the third one is spray type. From the name itself, you can understand. Gravity type means here only water can be flowing. Air cannot be making the gravity flow. And a diffused air type means here air only can be diffused. So we are supplying air into the water. And spray type means both can be possible. But you can spray only water into the media. But air spraying, it is quite difficult. Through the nozzle or spray, you can do something. But the air-water molecule interaction will not be efficient. So now each and every type of this aerator we will discuss now. What is happening in gravity type? From the name itself, we can understand in a gravity type aerator, the water will be flowing according to the gravity of natural gravity. Okay. So this type of aerator, they are maintaining very thin sheet of water on a large surface area, which makes that the large surface thin sheet of water when we are providing, the natural atmospheric air will give the agitation on the water surface. That because of this, the diffusion will take place. Because of that diffusion, whatever it may be, the carbon dioxide will be present, will be removed. Around 30 to 60% of carbon dioxide can be removed by this process, and which makes or which gives 0.02 to 0.05 meters square per meter cube of our capacity. For that, they have to show that they have made different types of gravity type aerator, Again, it is being classified in this gravity type aerator classified into cascade type and rectangular aerator. And another one is multiple tray aerator. How those aerators are working, we'll see. First one is cascade type aerator. Actually, this kind of arrangement you people can see in the slide how they have arranged, which is something like 3 to 4 to 6 steps of steps or trays they are arranging in such a way, and maximum they can be used only 10 steps. More than that, they will use it also, the efficiency will not be good. And in that particular process, they are making the rise and tread of each step supposed to be 20 to 30 centimeter gap only, should not be more than that. Steps means it is a concrete and normal steps only. Don't think that something else. The water is flowing on sides of the steps equally. When it is fall down on each steps, when water flows like that, the air will be interacted with the water molecule and it is diffused. When it is happening like this, whatever the carbon dioxide and other molecule presented will be evaporated. Evaporated means we can't say evaporated, that is evolved or liberated from the water surface. That is the thing is happening. When we are using this kind of step system for water treatment, there is a possibility to grow algae. To avoid this algal growth, the people are doing, they are giving the glazing on the surface of the steps, so there will not be any growth of this thing. And the velocity of the water to be maintained according to the load of the concentration or load of this pollutant in the form of carbon dioxide, ammonia, methane, hydrogen sulfide, and organic matter, how much water could be dispersed. Then they will calculate accordingly. They will do. This is very simple type, and it can be make it as a big size also. It won't take much laborious work, but the time taken for fall of water over the height can be calculated T equal to 2H by G into the power half. This formula and a very simple formula. You have to follow the H by G, which is nothing but what is the gravity according to the height, how fast the water could be fall down. That will be calculated in terms of time. And another one is multiple. These are very simple only, not much, but you have to understand what is the concept behind that. Did you understand what is meant by cascade type?
Yes, ma'am.
Okay. Then next
Yes,
one is multiple tray aerator. What is meant by multiple? From the tray name itself, we can understand that they will keep the n number of trays, and the number of trays, how it is be linked with the diameter, we have to think. Because here in the earlier type, the pipe will be at the middle, the water will be flowing from the gravity flow of water from the top to bottom. So we can understand the flow of water, how it could be. Either we can increase the area, decrease the area, we can identify. But this multiple tray type of aerator, here the area exposure for each tray available up to the inlet pipe. So the surface area provided for the interaction of air molecules supposed to be more than the cascade type. So they have used some formula that is which is nothing but the area available for aeration is pi r square. Pi r square, or pi r square means what? It is the surface area of circle. Here that based on the diameter of the pipe that they have considered DP. DP means diameter. Pipe 1, pipe 2, pipe 3, like that, etc. pipe they are taking. Hello? Pi d squared by 4, which is nothing but the area of the circle pipe. And they have added n number of pipe. They added and multiply with the pi by 4. They will get the area. Then how many number of pipe they can use with that particular height, they can calculate. They can increase or decrease the surface area which exposed to the area from the inlet. Here the area will be more area will be exposure into the air water molecule. The interaction is more. The volume of treatment of water is more, and the removal of carbon dioxide also little more than the cascade type. And another one is rectangular aerator. Rectangular aerator, which is nothing but cascade type only. There is no much more explanation about that. Then next one is inclined apron type. In the inclined apron type, what people are doing, they have riffle plates over here, and the riffle plate, they are making a set of herring herringbone patient technology, then the water molecule will be jumping from one layer to another layer. Like that, the speed of the water is being maintained. And in the absence of refill plate, they use apron also. Apron will give better result than the refill plate. And it is permanently fixed on the honeycomb structure. So this will work for quite a long time than cascade type and multi-type aerators. In an industrial process, if they wanted to treat their own water for the recycling process, somewhere people are following this kind of aerator for their own water treatment. And the figure will be there in your book. You can look at that. Then stakes of perforated pan and troughs. From the name itself, can you understand what is meant by perforated pan or trough?
Ma'am, is something with the hole or small outlets, perforated.
Okay. Yeah. Have you seen anywhere perforated everyday life? People are thinking
Everyday life. Any instrument or anything you are asking, ma'am?
Anything, anywhere.
Perforated.
हाँ मैम, किचन में होता है ना, वो किचन में यूज करते हैं.
What is that?
सीविंग मैडम, कुछ छानने के लिए, कुछ फिल्टर करने के लिए. हाँ.
The puri will make the ma'am. Puri.
हाँ.
Abgir.
People would make any coffee filter, tea filter.
हाँ, tea filter also.
You do, ma'am.
And
those are
not tea filter, ma'am.
Those filters are not called. No, I am going to ask further questions. What is the if you are telling that this perforation means, what is the difference between perforation and filtration? Why they have used two different terms? You got me?
Oh, ma'am, aroma we use, ma'am, aroma.
What aroma? Aroma means
that is perforated, ma'am. Aroma we use, ma'am. Room aroma. Yeah, ma'am. The machine will be done, ma'am. Perforated type. And I will keep some aroma item. Not that, ma'am.
No, ma'am. Perforated means small holes only, ma'am. That's all. So at the bottom of some pan.
Tea filter is perforation or not? Perforated or not? Coffee filter and tea filter are perforated.
Ma'am, tea filter is perforated. Yes.
Coffee filter?
Perforated one, ma'am.
Okay, why they are
and maybe the size of the holes where it is getting filtered.
Okay, then why they are using the term filter instead of perforated? You got my point?
Yes, ma'am.
Why they are using? Then they would have used the perforated, no? But they have used coffee filter and tea filter instead of our strainer, we are telling, instead of perforator. Okay. How many of you are there in the class today?
9, ma'am.
9 members.
Including you, 8, ma'am.
Okay. For all the 8, this is a homework for the next class, tomorrow's class. When you people come to the class, you have to get the answer for this. What is the difference between filter, perforator? Why there is a different name on a filter and perforator? Example for filters and example for perforators. Okay?
Madam, once again repeat, madam.
What is the difference between filters and perforators?
Filters we can apply pressure.
Filters and perforators. And
Okay.
example for filters and example for perforators.
Filter means RO.
My God. Very good. Yeah.
Maybe.
What is the filter mean?
Maybe the precision, ma'am. That's it. Precision and accuracy of the filter.
Okay. Anyhow, this is the homework for you all. Tomorrow, if I forget also, you people please open up. Understand?
Okay, ma'am.
Ma'am, those cigarette filters are there, no? Those are perforated. Huh?
I'm giving them the homework now. You please study well. If you are not answering also, I will answer. But how you are perfect, I wanted to see.
Okay, ma'am.
Understood?
Okay, ma'am.
Okay, ma'am. Okay, ma'am.
If you are doing like this, if you study well like that, in your lifetime you may not be confused. If I will say 2 days, you may remember. 3rd day, you may forget. Understood?
Yes, ma'am.
Okay, really, I like you all people. You have agreed the truth. Very good people. My students are really good.
Thank you, ma'am.
Hello? Okay. The next one is stacks of perforated pans and troughs.
I think the
From the
size
name
only,
itself,
ma'am.
we can understand. So my students,
No,
I am
don't be
telling
behind
you,
it,
you
Durgesh.
get
Tell
confused
tomorrow.
after tomorrow.
I think the
Okay,
size
3-4 times I
filters.
will read it. Sir, okay, I'll come to the where the natural percolation is taking place. Where the natural percolation is taking place.
Ozone, ma'am. Ozone. Ozone layer, ma'am.
Where the percolation is taking place? No, that is depletion.
Sorry.
This
That
is
is not
depletion.
perforation.
Clouds, ma'am? No, clouds, no. No.
No, percolation means what?
Ma'am, can I say if I'm just trying, just let me know whether I'm right or not. Filtration means we remove only unwanted impurities. Okay. Perforation means like we pass some liquid through it, and whenever we want to, I mean to say, pass through some small holes. But it is not the filtration of impurities.
Yeah.
Am I right, ma'am?
Actually, the size matters, ma'am. The size what it filters.
Am I right, ma'am?
Yeah, you are correct only. If I give homework means you take it as a homework, na? Why you are so curious to answer today itself?
We are at home only, ma'am.
Tomorrow we may forget, ma'am.
We are doing homework, ma'am. We are at home only, ma'am. We are doing homework.
Have to submit tomorrow only. Okay.
Okay.
Homework means after the class you have to sit and study. That is called homework. Okay. This is the homework I am giving. After the class over, you
But
study,
ma'am,
collect and take.
please tell me, ma'am, is it somewhat okay or not?
Somewhat okay only, but I am really worrying about you all. What is the natural process for water percolation? You cannot answer to me. I am really worrying about it because I myself told in the class many times. Okay, learning means teaching means there are two things. I can teach towards the exam point of view what is there in your book. This is there, that is there, this is there. I can read and I can tell you, okay. I can prepare a colorful slide, I can explain to you like that. But out of it, please. I will, if you don't do like this. Asha ma'am, you only.
I am on mute only, ma'am.
Okay, very good.
Somebody needs faster.
Okay, please listen me. Very important thing I'll tell you. Teaching means what? Learning means what? Teaching means you are supposed to have the knowledge about the subject. To give the knowledge of subject, that is called teaching. And education is what? Educating means you make you to write the exam to score the mark. That is also important. If you read out instead of one book, 4 books, you write the exam, you can score 80% of mark. That will not give subject knowledge. Knowledge is important than marks if you really wanted to perform in your life on subject wise. For scoring a mark 3-4 days or 1 week, you sit at home, you read your book, you can write an exam, but you cannot learn. Learning is very important. Learning means either you can learn by your own experience or by experienced people what they are telling, from that you can learn. But whatever you are learning, that you have to remember in your life, that is important. Simply today you are hearing, tomorrow you are leaving from this year to this year, no use at all. Some of the things which I am telling means I am working on it more than 20 years. From my experience, I am sharing with you people that I myself have practically experienced. Practical experience and many things I am sharing with you people. Really, people are highly opportunities to learn many things from me that I have learned from many years. 1 hour, 1.5 hours, I am taking class, I am telling hundreds of matters. Please learn it. It is useful. It is useful. Today, if you are a housewife also, house husband also, tomorrow when you are teaching to your kids or your grandchildren, that will be useful at any time. Or if when you are buying something or selling something, that time also what I am teaching will be useful. Okay. Now I am telling about what is the difference between preparation and preparation, which has a meaning. The same question may come in answer also. If you write any exam also, the same question will come. They will give 3-4 options. One is on preparation, another one is on preparation. Then what could be? You will be confused. To avoid that confusion only, because I confused. Somebody else have confused. They came and discussed with me. I have clarified. The same thing should not be with you. That's what I wanted to make it very clear. Understand? It does not mean that in the spot you just, if like that, I myself will tell. I will not ask you question. If something new, I myself will tell you. So this is new thing I will tell. Some of the things, it is a commercial thing. Everywhere we know that what is meant by percolation. If it rains, where the rainwater will go, which percolates into the underground. That is percolation. Understood? No? Everyone has gone.
Yes, ma'am.
Yeah.
Yes, ma'am. Rainwater percolates in the soil.
Percolate.
Okay, that is a better example. I am asking what is the day to day. Then what is the filtration? You please, now we have, many people are telling that filters are perforators. Okay, of course, that is true. And what could be? There must be two main difference. That's why they have used two different names. What is that? That is very important. Whatever we are learning, that we have to learn very clearly. Everything we learn flukily, it is okay. It is up to you. That is depending upon the person. I want to learn perfectly, you will learn perfectly. Okay, simply I will write and score mark and okay, you can have. No issue at all. But what I am teaching, I wanted to know my students supposed to be perfect on what I teach. Clear? So if I give homework, people try to understand. If we give answer tomorrow, also I will give more explanation. Isn't it? Yes or no? Simply you said, okay, leave it like that, I will not go now.
Yes, ma'am.
Okay, so if I give something, try to understand, please. Okay, now fifth time I'm reading. The another type is stacks of perforated pan and troughs. Whatever you people said, that correct. Here the people are using some type of pan and troughs which is having that perforation. Through that, when the people are passing that air, which makes some sort of structure, size, and how they made everything. Through that, the people are reducing around 65 to 90% of carbon dioxide. But this method, when you are wanted to do at very large scale, it is quite difficult. Okay, this is not much things to explain because they have arranged some of the trays. In the trays, they is filled with some inert media. That inert media such as gravel, any sort of that ceramic material or ceramic coke or bituminous, anything they can be. Through that, they are passing this water. Then there will be a possibility of flowing of water in air. The speed will be reduced. Due to that, the air-water interface or exchange will be taken place. Then the soluble gases will be removed. So through that method, around 65 to 90% of carbon dioxide could be released or removed from the water. And for that, they have given one expression, Cn equal to C0 into 10 to the minus Ka, where Cn is the concentration, initial concentration of the carbon dioxide at the first trough, and C0, sorry, it is a final concentration of after passing through all the trays. C0 is the initial concentration of carbon dioxide when it entered into the first tray. This difference between these two with some constant which give the efficiency of this unit. At the final tray, how much it could be the carbon dioxide. And the next one is cover with counter current flow of air and water. What is meant by counter current flow? Let me finish this lesson on only few words of something.
Opposite current, ma'am, counterclockwise.
Then what is another flow? Another method of flow. This is counter current
Against
flow.
gravity, ma'am.
Yeah, we are talking about the gravity only now.
Okay.
But
Yes.
it is counter current flow means the two fluids are passing through in opposite direction. They are called counter flow current system. And the two fluids are flowing through the same direction. They are called co-current flow system. Okay.
And what did you say? Second one?
Co-current.
Co-current.
Counter current and another one is co-current. CO.
Okay, ma'am.
Okay. COCURRENT, that is co-current, and the counter is COUNTR counter. In this, we are going to talk about only counter current flow of air and water. In this particular type of aerator, the water falls down from the top of the tower through the sprinkle, while air from the compressor or blower, which is coming from the bottom. The air comes from the bottom and through the nozzle, water comes from the top. When it moves, both are in the opposite direction. Somewhere here and there, this air and water molecule interface and interchange occurs. Then when the interchange is occurring, the air will be diffused into the water. Then whatever the soluble gases are there in the water will be removed. This method people generally used in many industries to remove the dust particles which are all present in the water also. We have discussed in air pollution and control technology how to separate the particulate matter. There I have explained about this method. Do you remember? When we were talking about the particulate matter removal in air pollution control technology.
Yes, ma'am. Yes, ma'am.
In the last class, I was talking about this. Could you remember?
Yes, ma'am.
Okay, good. The same technique. Here the people are using for, technique is same, but the different places the same technique will be applicable. Here they are removing the soluble gases by diffusion process, by counterflow effect. Clear? Next one is diffused type of aerators are available. Actually, this diffused air type of diffused aerator, they have done in two different ways. What are the two different ways? I will explain. And some of the mathematical equations are there that is not much important. Any one of the equation you may remember and write, that is enough. Okay. In diffused type aerator, here the size is very important. The depth is supposed to be 3 meter to 5 meter and width is supposed to be in the range of 3 meter to 10 meter length, and which gives the desired detention period. Detention period means what? In the last class, I have told you what is meant by detention period. What is meant by detention period? The time taken for particular process, that is called detention period. For example, last time we have seen about the sedimentation and the coagulation. The time taken for the coagulation process is called the detention time. The time taken for the sedimentation, it is called detention time. The time taken for the clarification is called the detention time. Here, the time taken for the diffused air process, that is also called the detention time. Detention time means the time taken for completion of one particular process is called detention time. Understood? So in this process, the detention time is varying from 5 to 30 minutes. 15 minutes also is being common. It's based on the width to depth ratio supposed to be maintained 2:1. It is optimum. Sometimes less than that also will be applicable. And the diffused air types. Diffused means what? The air is induced into the system slowly by the diffuser. That is called the diffuser. What they are using for the diffusion? There are two methods people are using for diffused air supply. One is they are providing some sort of porous plate at the bottom, either throughout the width of the bottom or only the ridge and furrow type, or along one side of the length they are providing that porous plate. And the second one is they are using suspended diffusion tube along one side of the length of the column or container. Either any method people can be used to diffuse or introduce air into the water. And air, exactly we will say means, you people, have you seen the microwave oven?
Seen what, ma'am?
Microwave oven, convection type, have you seen?
Yes, ma'am.
it is in my home.
Tell
Yeah,
me.
ma'am, we have. I know, ma'am. We have a magnetron.
Yeah. What is happening?
Magnetron is there, which heats the.
Magnetron will give you microwaves. In convection mode, magnetron will not be working. Convection will be giving only hot air. You have some heaters. That heater will be heated by your electrical heating. The outside air will be entering into that. That hot air will be generated from that. The hot air will be entered into the microwave oven, which will be used for cooking. That's what there will be microwave type, and convection type, and another one is grill type. These three are there. Understood? In a convection type, their magnetron will not be applicable. It is there in the same system. That time that will not be on. When you are using the grill lamp will be there. The grill lamp will be giving heat in the form of light. The tube light will be there inside. That tube light will be giving the heat. That heat will be useful for doing the grilling process. In microwave process, the magnetron will be there. That magnetron will release the microwaves. That microwaves will be useful for cooking. In convection, only heater will be there. That the heater will be useful for heating the outside air when it enters into the unit. Then it generates the hot air. That hot air will be useful for the cooking. That is convection. These are all the three options of involved in microwave oven. All three options are playing three different processes. I am correct or not, Nubia?
Yeah, ma'am.
Yes, ma'am.
Are you using microwave? All these three are different.
We are using
I don't use any of these, ma'am. But I know, ma'am.
You can do all types.
Okay, fine. You people are aware of it means, okay, if you don't know, still you want me to explain, I will explain. Okay, then convection type, when I told you, the air is entered, it heated, and the hot air entered into the oven, which is nothing but they have provided one perforation on the wall of the oven. Through that hot air will enter. That is called
yes, ma'am.
diffusion. That is called diffuser. Okay. So the hot air is diffused into the oven where you are keeping your food items will be cooked off. So like that, in a container, either at the bottom or at the side, they will provide the perforation plate, or they perforated or porous or diffuser tubes are available in the shops. That is in suspended form. That will be suspended along one side of the container, which will be diffusing the air into the container. The container will contain water. The air will be diffused into the water. Then air-water interface occur, exchange will occur, all sort of diffusion will occur. Then unwanted gases, dissolved form of gases will be released. So this is another way of working of this aerator. In this particular type, the size is very particular. It's supposed to be 2:1 ratio of width to depth. Okay. Then satisfactory result will be obtained in diffused air type by the spiral flow. Either it will be available in one half of the water depth, which reduce the required air pressure, because here air pressure is supposed to be given a little more. For that, people are using some compressor with low capacity. This compressor sometimes will get some dust particle also, sometimes which block that holes or diffuser. To avoid that, the people will be using some sort of cleaning agent inside that to remove or accumulation of dust particle inside that. And also sometimes there is a possibility to deposit oil particles or oil film to reduce that. Inside the trap, they are using oil trap to trap the oil. So if you are providing all those things, the unit will be working for a little longer time. The industrial application, this kind of diffusers people are using, especially wherever they wanted to get that pure water without any dissolved components. There they are using this type of aerator. Clear? And for that physical parameter, they have given some of the thing in your book. It is not much important, but one or two equations you try to remember. And another one is spray type aerator. What is from the name itself, we can understand that in a spray type aerator, the water will be sprayed, and that makes the water will be sprayed into the air, that is from the stationary or moving orifices or nozzles. Because of that, which makes the whirling motion. Whirling motion means we can there that is something like a centrifugal motion what we have seen in that air pollution control technologies, which imparted to the droplets makes few turbulence in the water and air, which makes the water air interface. Then normally the nozzle and orifice, whatever they are using, this purpose is supposed to be used. The water is supposed to get little more organic matter. There only this kind of technology will be used. Again, I will tell you here the water will be nozzled through orifice into the air, and which makes the swirling motion inside the container. And whenever the organic pollutant load is more in the water, there only this kind of spray type aerator is being used. And when that whirling motion happened, there the air or air-water interface started occurring. If the interface started occurring, means there will be a diffusion of air into the water will be occurring. Then it is liberate or remove the soluble gases. This is the thing is happening. For that, they have given one or two equations. Yes.
Ma'am, is it same as fire for extinguishing fire? No, ma'am. These things are there on the ceiling, no, ma'am, of some places. So are these same sprays, ma'am?
No, there will not be any interfaces are occurring, no. Here interface means what? When the water enter into the air or air enter into the water, when it is the air is trying to enter into the water molecule. When it is trying like that, whatever the solubilized gas in water as in the form of carbon dioxide, ammonia, hydrogen sulfate, methane, that will be removed out because that may not make the compound with water. You understood?
Yes.
If anything make a compound with any product, that is very quite difficult to remove. Which is solubilized, that is in the form of gas. So this kind of interface exchange is occurring. That time any unwanted things are there, who are all volatile nature, those things will be removed.
Okay, ma'am.
Is it clear?
Yes, ma'am.
When in firing things, they are spraying water through the nozzle at a high pressure, high velocity. When it hits means the temperature will fall down fast. That is the concept over there. There is no much engineering involved on it.
Okay.
Clear?
Yes, ma'am.
So this is about the aerators. This is one of the very important lessons. I am telling you, first is 8 or 10 lesson of this paper are very, very important lesson. Till the disinfection. And up to 9th unit, all are very important only. And in that, in the first 6 or 7 unit are very, very important. Up to sedimentation, it is important. Sedimentation, flagellation. Sometimes people are asking about the filters and filtration process also.
Okay, ma'am.
This is about the aeration and aerators. And if I forget also, you people please remind me. I have to explain more about the lesson 11, unit number 11. From unit number 11, minimum 2 or 3 questions will come all the years.
Okay, ma'am.
Okay. Okay. Any questions till now?
No, ma'am.
Any questions? No. My students are very good students. They never ask me that. They're okay. Shall we terminate the class?
Your wish.
Any question? Your wish, my God. That means what? Anything else is there? If you have, please ask me.
No, ma'am.
No, ma'am.
Okay, thank you. Thanks to every one of you.
Thank you.
Thank you, ma'am.
Okay. Tomorrow I will take the class in the first session.
Ma'am, tomorrow when is the class, ma'am?
10:30 I will take. Okay.
10:30 to
12 o'clock.
Continuously at 12.
Okay, ma'am.
10:30 to 12. Again, I will take from 12:30 to 2. Is it okay for you? Or 1 to 3 minutes? Please tell me now itself.
No, ma'am. Not till 3.
Huh?
12:30 to 2 is fine, ma'am.
morning session is good, ma'am. We'll be active.
10:30 to
yes, ma'am.
Okay, fine. First session 10:30 to 12, and the second session I thought of take 12:30 to 2. Is it okay?
Yes, ma'am.
Ma'am,
That is
ma'am is
fine.
asking for 2 sessions. Ma'am is asking
we have
for
to have
continuous 2 sessions.
12:30 to 2 is fine,
I-
ma'am. Don't make it 1 o'clock to 3 o'clock.
Okay, fine. I also need to have drink water, coffee, something else. You know, I have to talk continuously 3 hours.
Yes, ma'am.
Morning time, your class will be good, ma'am, because these are all technical things, ma'am, which is taking some
Yes,
time
ma'am.
to understand.
Try to learn.
After afternoon, we'll feel
Ma'am,
sleepy,
we
ma'am.
can
Cannot
take a
understand.
break in the middle, madam. 10 minutes. We can take a break in the middle.
Half an hour I am giving, no? 12 to 12:30.
Okay,
Yes,
madam.
ma'am.
Fine.
Okay, before 10:30, Ashram will finish your cooking, feeding,
Yes.
everything.
Yes, ma'am.
Chapati is there, roti is there, don't say.
Ma'am, we can't eat biryani in half an hour, ma'am.
That's what I asked you. Shall I give 1 hour or shall we start at 1 o'clock or 12:30? Okay, you people tell me in the morning because I have to tell to Rajita madam. She's only coordinating now. She's also Pavam Kala. She also has to make biryani. She also has to eat biryani. I won't make biryani tomorrow.
I also don't cook, ma'am, on Sundays.
Okay, very good. Okay, then all the best to every one of you. Morning. Please tell me now itself 1 to 2:30 or 12:30 to 2. Please tell me now.
I'm saying 12:30 to 2, ma'am. You can ask others what are they comfortable with.
Okay, Durgesh, what about you?
The more the time passes, this thing
Yeah,
will
it's
go,
okay,
ma'am.
ma'am.
Saturation
It's
point
okay.
will go.
Okay, 12 to 12:30. Try to eat half an hour within half an hour biryani. Okay.
Okay,
Only
ma'am.
one
Okay,
Sunday,
ma'am.
2 Sunday. Please sacrifice
Yeah,
yourself.
okay. Okay, ma'am.
Okay, ma'am.
Thank you.
Thank you, ma'am.
Okay.